We're going to do a little bit with matter today. Definition of matter is that it has mass and it takes up space. There are two main categories of matter. Again, like I said, this should sound, I said this during class, I think this should sound familiar to you because it's chemistry stuff. Pure substances are either elements or compounds. Elements, you need to know the definition of. There's only one type of atom. You can use the periodic table and write a symbol for it, like carbon or hydrogen. Compounds are made up of two or more chemically joined atoms. So it's not two things just sitting side by side, they're chemically joined together. And you can write a chemical formula for that, like carbon dioxide or water. So both of those elements and compounds both need to be defined for your objectives. Elements have different isotopes. We're not going to really get into too much detail with this. Some isotopes can be radioactive. And these isotopes can be used to determine the age of samples at a crime scene. For instance, carbon-14 dating of tooth enamel can be used to determine the age of a person who has died, a decedent. The other type of matter is mixtures. They're really things that are sitting side by side. So salt water, for instance. They contain more than one element, but they're not chemically joined together. So we have water sitting side by side with salt. This is a mixture. Solutions are what we've been working with. You guys learned what a solvent was. It was what was doing the dissolving, what was used in the chromatography to separate the mixture. A solute is what gets dissolved in the solvent. This is also an objective. The states of matter, or phases of matter. Solid, liquid, and gas on Earth. Solids have a definite shape and a definite volume, and they have the lowest kinetic energy. So the particles within a solid are moving very slowly or just vibrating very slowly. Liquids have a medium amount of kinetic energy. They have a definite volume, but its shape can change depending on the container it's in. Gases don't have a definite shape or volume. Both can change. You can change the shape and the volume of a gas. The particles move rapidly. Gases are what you see at room temperature. Vapors are liquids or solids at room temperature that are heated to vaporize. Another objective here. Changes in state are called physical changes. They're reversible. You're not changing the compound itself. Boiling and condensing are the opposite of each other around the boiling point. Melting and freezing, depending on which direction you're going, are the opposite of one another around the freezing point. Sublimation is going straight to the gas phase from a solid, like dry ice. Like I was emphasizing before, freezing point and melting point are the same temperature. Boiling point and condensation are also at the same temperature. Physical properties are characteristics that can be observed without changing the material itself: color, mass, density. Chemical properties can only be observed when there's a change to something else, like a new compound is formed, burning or decomposing. Physical properties, some examples: boiling point is one of them. Solubility is another. You don't have to know any of this, so I'm kind of zooming through these. Affinity for a solvent, that's what we've been working with in terms of chromatography. We already talked about all this. And density, we've also discussed already. Mass divided by volume. This is another physical property and some extra information here. Other physical properties: color, odor, physical state at a certain temperature. It's a little difficult with chemical properties because testing chemical properties, whether it can burn, if it burns, then it's destroyed. So is it combustible? Is it able to be corroded? We add acid to it and it destroys it, then it's gone. So you have to split the original sample so that you have some left over. Qualitative analysis is looking at the qualities of something, combining with other chemicals to see if there's a positive test or a change in the substance. This is another thing that you need to know, objectives-wise. Qualitative analysis is just using the characteristics or the qualities of something, as opposed to quantitative. Quantitative refers to the quantity of something. Quantitative analysis involves numbers, so we're actually collecting numerical data and taking measurements.